So, take a look at your periodic table. Everybody, look at the periodic table. Everybody see the periodic table on the wall?
Yeah.
What number represents your atomic number?
The one underneath the symbol.
The one underneath the symbol?
No, the blue.
It's the blue number. So in this case, it's in the upper right. Man, it's hard to talk and write at the same time. So if you look at my hydrogen on the periodic table, this upper right number right here represents your atomic number. And what is the atomic number?
The number of
The number of what?
Yep.
This is the number of protons.
Oh, I got it right.
Yeah. Hey, what characteristic dictates what element we're talking about on the periodic table?
The letter?
Well, what makes the letter the letter?
The atom.
I actually don't know.
No.
What did you say? The question.
What makes an element the element we're talking about?
How many electrons, protons?
How many electrons, protons, and neutrons?
Yes.
No.
The makeup of the atom.
Oh, yeah.
Number of protons.
It is the number of protons that makes an element the element we're talking about. So if we talk about carbon, how many protons does carbon have? Can carbon have something other than 6 protons? No. If we have 7 protons, it's no longer carbon. What is it? Nitrogen. If we have 5 protons, it's no longer carbon. What is it? Boron. So again, the number of protons is equal to the atomic number, which defines what element we're talking about. Look at this first example up here. I have the atomic number as 101. What symbol does 101 have? MD. This is Mendelevium. Mendelevium is credited with designing the periodic table that you see today. He discovered a lot of trends on it and designed the periodic table as a result of those trends. Now, Mendelevium has an atomic number 101. What else can we fill in? The number of protons. We know it's 101 for the protons. Hey, what makes up the mass number of an atom? Or where can I find that mass number on the periodic table? Anybody want to show me? The bottom?
Yeah, like the.
Yeah, that was a trick question.
Are we supposed to
Because
write
it's the
that short
neutrons and the
name?
protons what gives you the mass.
That was a trick question. The mass number is not on the periodic table.
No, that's the weight. And the proton.
The average atomic mass is on the periodic table. The mass number is not. So, what makes up the mass of an atom?
Neutrons and protons when you sum them.
Mass number equals protons plus neutrons. Why do I not include electrons in this? What?
Because if the atom
What'd you
doesn't
say?
have any
No.
well, if the atom doesn't have any charge.
I don't include electrons with the mass number because compared to protons and neutrons, electrons are essentially massless. They have such a small mass that I don't include them in the general relative mass of my atom.
Well, aren't they all just so small?
Yep.
Or what all so small?
Like neutrons, aren't they all?
Yeah, they're all small, but comparatively, if you look at a proton, neutron, and electron, an electron is so much smaller than protons and neutrons that we essentially think of an electron as almost massless. Okay? Now, look back at your table. I have a mass number of 258. I know my protons plus neutrons must equal 258. 101 plus what equals 258? 157. I must have 157 neutrons. Last, charge. What two subatomic particles have charge? protons and electrons. So, if I have more protons than I do electrons, my overall charge will be what?
Positive.
Positive. If I have more electrons than protons, my overall charge will be negative. Look at my protons and neutrons here. I have 101 protons, I have 101 electrons. They're the same, so what's my overall charge? 0, neutral. So your charge is going to be protons minus electrons. Now, this given information here is how you fill out any of these tables that you may see in the future. And you will continue to see these tables for the rest of the school year. So I want you to go ahead and fill out this chart for me.